Hey everyone, welcome to the Solving Polynomial Equations video. Today we are going to learn how to solve polynomial equations, which we've never solved equations that have exponents in them before. So the very first thing at the very top, we're just going to go over some structure things first so that we understand exactly what we're looking at, okay? All of our polynomials today that we're solving are going to be in what's called factored form. If you look up here at all of these factored forms, you will notice that all of them have parentheses. Factored form means you are changing it to a product, and a product, two things being multiplied together. Now we're going to practice with one really quick because I just want to reiterate this. If you know what x is, this is just a number and this is just a number that are being multiplied together. We don't write that multiplication dot because that's what the parentheses do for us. And that's it. Okay, so what we're going to do is we're going to evaluate this for x equals 7, which means rewrite it but replace the x with a 7. So 7 minus 5 and 7 plus 2 instead of x minus 5 and x plus 2. Now, 7 minus 5 is 2. 7 plus 2 is 14. 2 times 14 is 28. Done. Not as hard as you thought it was going to be, was it? The second one, I'm replacing the x with negative 2. So negative 2 minus 5, negative 2 plus 2. Negative 2 minus 5 is actually negative 7, but that doesn't end up mattering because negative 2 plus 2 is 0. And so negative 7 times 0, 0. Now let's try it with 3. 3 minus 5, 3 plus 2. Negative 2 times 5, negative 10. And one last one, 5. 5 minus 5, 5 plus 2. 0 times 7 is 0. Why did the 2 that equals 0 equal 0? Because one of the numbers was 0. Try to think of something that multiplies to 0 without using the number 0. You can't. If two things are going to multiply to 0, then one of them has to be 0. So the two solutions to the equation equal to 0, if I set this equal to 0, would be 2, negative 2, and 5. Because those are the two answers that gave me 0 as the answer. So those are the solutions to that equation. Now by the end of notes, you'll be able to solve that yourself without having to plug numbers in. Because how annoying would it be if you were just guessing and checking like that the entire time? Okay, the whole point of that was to realize each set of parentheses is a number getting multiplied by the other set. We just don't know what x is yet, so it looks like it's not one thing. Now, we are going to use the zero product property for the rest of notes. It's a really, really, really important rule in math, and it says that if a times b equals 0, then either a equals 0 or b equals 0, or both. Because 0 times 0 is also 0, right? Like, more the merrier if they're both 0. How we use this to solve polynomials is either this factor equals 0 or this factor equals 0. We're going to solve for both possibilities. That's it. Factors are set up as products so that they can multiply to 0. One last thing before I actually solve this first one. This only works with 0. If the number on this side is not 0, you cannot use this. Just FYI. All right, let's dive into a couple. When an equation equals 0 and you've got multiplication going on over here, that means either 2x, the thing outside, equals 0, or x minus 4 equals 0. Because if x minus 4 was 0, and you replace that right here, 2x times 0 would equal 0. Now, if 2x equaled 0, 0 times x minus 4 would also give me a full answer of 0. So if either of those two spots becomes a 0, the whole thing becomes 0, which is what we want it to equal. So then you just solve both equations. That is the idea behind this entire lesson. To solve the first one, I would just divide by 2. 0 divided by 2 is 0. The other one, I would add the 4 to the other side, and x equals 4. That's it. Not so bad. But you can't set that up unless you understand the zero product property. The next one you'll notice has actually two sets of parentheses. So either x minus 3 has to equal 0, or x minus 9 has to equal 0. Which means my two possible answers, if I get x by itself, I'm either going to add the 3 and get 3, or I'm going to add the 9 and get 9. Since you're adding to 0, it's really not so bad, is it? Okay, we've got one more up here on the top row. It has 3 parts, so guess how many answers it's going to have? 3. 3y equals 0, y plus 2 equals 0, and y minus 7 equals 0. And you got to solve all 3 of them. Good news is they're really not that hard to solve. Divide by 3, you get y equals 0. And I'm just going to put a comma in between this time. Subtract the 2, you're going to get negative 2. Add the 7, you're going to get 7. Because there's a 0 on the other side, your operations are pretty simple. Hopefully that's starting to click in a little bit. There are a few things on the bottom row that make it a little more complicated. If you happen to see this squared, keep in mind that when we did that with multiplication, we just needed to write it twice, right? So then we would just be solving w plus 8 equals 0 twice. Is that going to give us different answers? No. So your answer would just be negative 8 when you subtract that 8 to the other side. That is called a repeated answer because it was on there twice. You don't have to write that. Just know that it's okay if the parentheses gave you the same answer. You don't have to write it twice. So that's what you do with the squared. The middle one is a little tricky because the answers are going to be fractions. I have to solve the equation 3 plus 2b equals 0 and 1 minus 4b equals 0. Now, I have to subtract this 3 to get rid of it, and I'm left with 2b equals negative 3. And this is where a lot of us already start the next step as we're writing it down, and we're like, oh no. Because I got to divide by 2, and negative 3 doesn't divide by 2, so guess what? Negative 3 halves is my answer. That's it. With the second one, I would subtract this 1. 0 minus 1 is going to be negative 1. And then I would divide by the negative 4. I can't divide negative 1 by negative 4, but I can rewrite this as positive 1/4 because those two negatives would cancel each other out. All right, one more before we move on to the next topic. 2b plus 5 equals 0, and 4b minus 3 equals 0. You're just setting each factor equal to 0. A factor is either a thing inside the parentheses or a thing in front that doesn't have a plus or minus, like 2x or 3y. On the left side, I would subtract the 5, and I'm just going to go ahead and write 2b equals negative 5. And then I would divide by 2. Can't divide 5 by 2, so negative 5 halves is my answer. Second one, I would add the 3 to the other side, which would give me 4b equals 3. Divide by 4, so 3/4 is my other answer. Don't be scared of the fractions. You're going to see a couple fraction answers. They're not that hard. We're just less comfortable with them because they aren't nice and pretty integers. All right. Fun fact, by the way, the number of solutions a polynomial has is equal to its degree. So an x cubed polynomial will have 3 answers. X squared will have 2, x to the 4th will have 4, and so on. Just a little tidbit. You'll talk more about that in Algebra 2, though. All right. What if the parentheses are not already there? Notice how all these at the bottom aren't in factored form. So we have to factor. Factor means you're turning it into the parentheses. What we're going to do today is find the GCF, greatest common factor, which is the biggest thing that everything in the polynomial, each term, can be divided by. So for the first problem, start by looking at the numbers out front. And we're just going to factor these. We're not going to solve. We can't solve something that doesn't have an equal sign in it. Now, what's a number that goes into 8 and 24? 8. 8 is the biggest number. 2 and 4 both go into it, but 8 is the biggest. Now, also, they both have a y. So we're going to put 8y out there. And that is what we're going to divide both of these by. Because we're trying to unmultiply by turning it into a multiplication problem, right? And unmultiplying is basically just a fancy way of saying divide. 8y squared divided by 8y is just going to be y. Because the 8's divided to 1, you don't have to write the 1. And y squared divided by y takes away one of those powers. And then negative 24y divided by 8y is negative 3. Because negative 24 divided by 8 is 3 and the y's cancel. Now, I'm going to erase this and backtrack. I'm not wrong. You don't have to erase it with me. I just want to explain one other way your brain might find it easier to think of. Once you decide that your GCF is 8y, you're pretty much deciding 8y times what gives me 8y squared. Well, it just needs another y. So 8y times y is 8y squared. And then 8y times what would give me negative 24? Well, it needs to be multiplied by negative 3 to get to negative 24. That's it. That is more like the undistributing I was talking about, where you're really just thinking, if I had to distribute and get back to my original problem, what should go here? Does not matter which way you solve it, guys. Take whichever one makes sense to you. All right, this bad boy in the middle is a little trickier because everybody wants to say 6. But 6 does not go into 16. 2 does. 3 goes into 6, but not 16, so it's just 2. Then there is an x on both of them, and there's actually 3 x's here and 2 x's here. So what can I take out of both of those? 2 x's. So I'm going to divide the numbers in front by 2 and take away 2 of the powers. For example, 6 divided by 2 is going to be 3. If I take away 2 of these x's, I have an x left. 16 divided by 2 is 8. And if I take away 2 x's, I don't have x's left at all. There you go. Divide the numbers out front, and it's really like you're subtracting your exponents. Because when we divide, we subtract exponents. Now the next one doesn't have a number in front, so the only thing you're allowed to take out as a greatest common factor is x. Because they do both have an x. And that'll just leave you with x minus 4. Because the x squared takes a power away, turns into x. Negative 4x take a power away is just negative 4 without the x. That is how you factor. Now, why in the heck are we learning how to do this? So that we can solve equations like we did up top, if they're not given to us all ready to go. For example, over here on the left, the GCF of 2x squared and 8x is 2x. And if I divide those both by 2, I'm going to get 1 and 4. The x means I take away a power, so I have just x, and then next to the 4, nothing. That's factored. That's all you had to do. Now, we need to solve it by saying either 2x equals 0 or x plus 4 equals 0. divide by 2, x equals 0. Subtract the 4, x equals negative 4. Six n squared minus 15n. I can't divide both of those by 6, but I can divide both of them by 3 and an n. 6 divided by 3 is 2. Negative 15 divided by 3 is negative 5. And then take a power away from from n. The n squared turns into n, and the other n disappears. Now, to solve the rest of the way, 3n equals 0, 2n minus 5 equals 0. So n is either 0 or positive 5 over 2. I guess I should just put a circle there. Last one, 3 and 9 can both be divided by 3. They both have an m. Just remember that 3m divided by m, 3m squared divided by 3m is 1m. You don't have to write the 1. Negative 9 divided by 3 is negative 3, and the m is now out front. So either 3m equals 0 or m minus 3 equals 0. Remember that those are very different operations because that 3 on the m is being multiplied, so you have to divide to get rid of it. The other one is being subtracted, so you add to get rid of it. Now, 0 divided by 3 is 0. 0 plus 3 is 3. There are going to be parts of this where you are able to show less work, and that's okay with me.